We found a way to have the computer check over all of our data records to see if there are any not available or NA values for our par data. But ultimately, we want to be able to check all of our data to make sure that they make sense. Now, we could look at the data as a table, but there are 72,794 different observations in this table, and it seems somewhat impractical to try to look over each of these records one by one and make sure they make sense. Ultimately, it's much easier to look over lots of data if you make a visualization of some kind. In this case, if we want to plot the time series of data, we can just look over the data to make sure that we have high power when we expect it and low power when we expect it, just to get a general sense if the data look okay. So ultimately, we need to find some way to plot all of our data. And these data go from approximately sometime in the March through sometime in November. So there is quite a lot of data, but it's relatively feasible to think about looking through a summer's worth of data if we were to plot the data, say, every week, so 1 week at a time. And perhaps we could make a whole book of plots as a PDF file, letting us look at the data 1 week at a time to make sure that they make sense. How do we get started with that? Well, let's go back to our R Markdown file. Perhaps we're in a new section of our report now. We've finished reading the data and putting it together. Now maybe it's time to do some data visualization. So I'm going to put a new Markdown top level header here, and I will start a new R chunk with the code that I need for that visualization. Now, as a first step, we need to get our time into some sort of format that we can actually plot. As we've talked about before, if I do a type of on the time column or the timestamp column, it's a vector of characters. And I can do a class on it as well to confirm that it's a relatively simple data structure. It's an atomic vector of character strings. Now that would be fine if we wanted to plot versus time as a category, but that means every individual time would have to be its own category, and take my word for it, that isn't going to make a very pretty graph. What we're going to need to do is turn our timestamp into some sort of numerical version of time that will allow us to use some of the tools in R's graphing toolkit for plotting data versus time. So in the first thing that we might need to do in our new code chunk is to generate a new column of our table. And I'm just going to call that column time. Different from timestamp, which is a character string, this time it's just a numerical time. And the function I'm going to use is called as.POSIXct. POSIX is a data type and a way of thinking about time that goes way back to the initiation of Unix as an operating system. So it's been around a long time, and the POSIX as implemented in R uses the same system for keeping track of time. Now the as.POSIXct, as many other functions that start with as, are a way to force one data type into another data type. So in this case, we're going to force our character string timestamp into a numerical data type called POSIXct. So the first argument to as.POSIXct is going to be, well, what is the vector of values that we want to force into a numeric time? That's going to be table $timestamp, the timestamp column. And ultimately, these timestamps, let's go ahead and look at the first value. They're a character string, but they follow a common format. They have a 4-digit year, followed by a dash, then a 2-digit month of the year, followed by another dash, and a 2-digit day of the month, then a space, then a 2-digit hour of the day, and in this case, it's going to be a 24-hour time, colon, minutes of the hour, and colon, seconds of the minute. So ultimately, we need to just tell the computer how that format works so that it can turn this character string time into a numeric time. Now the function that as.POSIX uses to do that is a function called strp time. Now we're not actually going to use this function ourselves, but I want to do a help on it because the help for strp time tells us how we can define a format that will allow us to turn a string date and time into a numeric date and time. So there are all of these codes that start with a percent sign that can allow us to define a format so that we can tell R specifically how to interpret these text strings and turn them into a time. The argument we use for that is called format. And what we pass format is a character string using a combination of these codes and the characters that divide the different components of time. For example, for this particular format, we're going to use a %y to designate that the first part of the string is going to be a 4-digit year, and that's a capital Y, %Y. Then we're expecting to see a dash, so I'll put a dash here. And then the month of the year should be a lowercase m. And you can find that code over here. You should find that the lowercase n is month as a decimal number. Then another dash, and we want the day of the month. And the day of the month is the D, %D code. So if we go to %D, it's day of the month as a decimal number. So that gives us our date, and then we have a space, and we need to put in our time. The code for a 24-hour, hour of the day in a 24-hour time is going to be a capital H. Then we need a colon. The minute of the hour is a capital M. Again, we can find that here, minute as a decimal number. And finally, the second of the minute is a capital S. Second is an integer. So this is how you define a code for the format that lets R know how to break this string down and turn it into a time that it can then turn into a numeric time. Now we can get away with doing just this and getting a result. So let's go ahead and see what happens when I run this code. I'm just going to go ahead and highlight the code, hit Control Enter. I could also hit this run button to do the same thing. And now I can look at what's in my table. Whoops. I can look at what's in my table $time column. Now it doesn't look that different. It's still showing us a character string. You can see quotes around each one, but there is one thing new, and that is a time zone. It's telling us MST. Now the first time is 2021, March 4th. That's when we started. And we started at 12:30 in the morning, or at least according to this. Again, on the data logger, this is UTC time. But it's showing it as MST time. That's Mountain Standard Time, US Mountain Standard Time. And that's actually a problem. Why is it doing that? Why is it saying Montana Standard Time? We've been saying all along that this is a time in UTC. I wasn't actually out at 12:30 in the morning in Montana putting out this data logger. It's actually out 6 hours earlier than that, which is actually Montana Standard Time. But it's saying this is Montana Standard Time. So this gets us into dealing with time and R and how to do it in a way that won't give you headaches. So first of all, let's double check what our new type is here. I'm going to do a type of on table $time. And you can see, oh wait, it's not a character anymore. This is a double, meaning the foundational data structure here is an atomic vector. And that atomic vector is a double precision floating point number, or a real number. Now, if I look at the class of this column of my data frame, it's going to show it as the POSIXct class, which inherits from the POSIXt class. So this is now a numeric time, and we can look at it as a number by using the as numeric. Again, in R, we have all of these as functions that help us force one data type to another. So if I want to see what table $time, and I'm just going to look at the first element of it, we can see what that looks like as a number. And it's this really big number. It's 1,614,843,000. Well, how is that a time? How is the computer keeping track of that as a time? Well, again, we can use attributes to think about the perspective on this as a time, and we can think about how the computer thinks about this as a number. In this case, the computer is saying the number of seconds since a particular epoch, a particular point in time that we're going to use as a reference. And for the case of POSIXct, that reference is midnight on the morning of January 1st, 1970. So we have a particular point in time that we think of as our reference time, an epoch, and we think of that in UTC. And then the computer will say, how many seconds has it been since that particular time? And that's what this number is. So that's how a computer can take a single number and turn it into a particular point in time. And then it all then depends on your perspective on time of how you think about that number. Now, if we look at the attributes of time, we can see that it has the class attribute that tells us what the class is of this particular R object, but also has this attribute called T-zone. And that attribute is going to keep track of which time zone you want to see the time in. And you can see that the T-zone here is blank. And that is why, even though the time as we know it from the file should be in UTC time, that's why we're seeing it as something other than UTC, why we're seeing it in the MST time zone. Now, this doesn't say it's in the MST time zone. What's happening is because the time zone is blank, my computer is saying, oh, well, I don't know what other time zone to think of this in, so I'm just going to use the system time. And this is the time that my system is in. It's in US Mountain Time, which at the current time of this data, in March of 2021, that would be Montana Standard Time, as opposed to Montana Daylight I'm sorry, not Mountain, Montana Mountain Standard Time instead of Mountain Daylight Savings Time. So this is actually a problem. What we've done so far is not going to be a very robust solution. Now, it just so happened that we did collect this data in US Mountain Time, and therefore it would be correct if we had collected our data using US Mountain Time. But because this is also confusing, and because of time zones and because of daylight savings time, it's much, much easier to think of this in UTC. So if we want to correctly convert this time to a time in the computer that is reliable and will work on any computer system we put it on, not just one whose system time is Montana, US Mountain Time, or UTC for that matter, we need to tell as.POSIXct what time zone this time is in. And we're going to use UTC as the time zone that is Coordinated Universal Time. And that is basically a reference time that's independent of any time zone that gives us a way to keep track of a given moment in time across the Earth as a whole. And that is the time zone. It's not really a time zone, it's a time reference that these data are in. This time, 2021, 0304, 0030, should be in UTC. And I should be reading it as UTC for it to show up correctly as time. So let me rerun this code. We'll look at table time again. And note that the time doesn't look any different. It still looks like 2021, 0304, 0030, 00, but now it has UTC here. And it says UTC here, even though my computer system isn't in UTC, because if I look at the attributes of that column, you'll see now it has a defined time zone. And I'm looking at the time zone in UTC. And this is correct. This matches up now. If I look at the first time, I can see that I have 12:30 in the morning. That is UTC time, and that is the moment of time in UTC when the first data point was gathered by this particular deployment. So it's pretty critical when dealing with time in R to make sure that you are giving it the correct time zone and it's storing it as the correct time zone. Or you will give yourself lots of headaches later on, or you may create a problem where your code won't work if you put it on another computer that's in a different time zone. So ultimately, it's really good practice for the data you collect to always use UTC, and then always read it in as UTC, and then don't turn it into a time zone until you have to for a given analysis you're trying to do, which we'll look at a little bit later.